President Kelly Beatty is back again, and this time she's here to present Mysterious Mars. Kelly was a Sky and Telescope Senior Contributing Editor from 1974 to 2018, and also served as editor of Night Sky, a magazine for beginning stargazers in 2004 to 2007. After 43 years of pounding the keyboard, he retired from full-time work earlier this year, but he remains actively involved in many Sky and Telescope articles, tours, and other projects. Specializing in planetary science and space exploration, Kelly conceived and edited the new solar system, considered a standard reference among planetary scientists. He also taught astronomy for 6 years at the Dexter Southfield School in Brookline, Mass. Let's give a warm welcome to Mr. Beatty.
Thank you very, very much. So before we get started, we're actually going to take a picture with everybody's got their glasses on. Let me warn you, wait, the red one goes on the left and the blue one on the right. If you do it backwards, your head explodes. Okay? So put them all on and we'll take a nice picture here. Face her.
I think you're right.
Yeah. We'll do over here. And everyone, like, we'll just take one normal, right? Right?
Okay.
Now, can everyone do the Vulcan thing? I think that would be fun to do, right?
All right.
That's great.
Everybody.
Thank you. That's great. Okay, so we're going to go to Mars tonight. And this is Mars in 3D, the planet next door that you've never seen it before. And we'll get started just as soon as the Martians finish crossing this one. Okay, we're not going to be using the glasses for the first part. Mars is a planet that has captivated our imagination for centuries. And we now know that it's about half the size of the Earth. And that means, if you can remember your high school geometry, or if you haven't had it yet, that the surface of Mars is about 1/4 the size of the area of the surface of the Earth. But Earth is 3/4 covered with water. That means that the surface of Mars roughly equals the amount of land on the Earth. It's an interesting comparison. A couple other things about Mars I want to point out. It goes around the sun in about 800 days. Right? That's a little bit more than 2 Earth years, 2.2 Earth years. But Mars has a polar axis. It's tipped very much like the Earth is. So it goes through seasons just like the Earth does. Summer, autumn, winter, and spring. I think that's the right order. I'm from California. We don't really have seasons out there. Mars also has an atmosphere, a very thin atmosphere, about 1/100th as dense as Earth's atmosphere, made up of carbon dioxide primarily. You know, I study the planets. It's an interesting thing about atmospheres. The clouds in a planet's atmosphere are always made of a minor component of its atmosphere, if you think about it. The clouds on Earth are made of what? Water. Is water a major component of Earth's atmosphere? No, it's like at the 1% level. On Mars, the atmosphere is carbon dioxide, and the clouds are made of water too, mostly. On Jupiter, the atmosphere is hydrogen, and the clouds are water, ammonium, and ammonium hydrosulfide. Minor constituents that condense out at the temperatures of the atmosphere. If you think about it, this makes sense, because if our atmosphere was mostly water, and if it was always condensing out, we'd have no atmosphere, right? It would all fall to the ground. Anyway, the other thing I want to point out is that Mars has a day, or a sol, S-O-L, to keep the two straight, that's just a little bit longer than a day on Earth. Now, astronomers knew pretty much a lot of these things a long time ago. We knew that Mars rotated. We knew that it had an atmosphere. We knew that it had a day very much like Earth. And so we've been looking at Mars for a long time through our telescopes, trying to figure out what it's all about. This is a typical picture of what Mars would look like through a really good telescope. And you can see some things on it. You can see bright and dark markings, modelings. You can see that there's a bright spot down at its pole, which is, in fact, a polar cap. In fact, there's one at both poles. And so we're looking at Mars through this telescope and we're saying, gee, I wonder what that kind of place is like. Interesting story is that when I was growing up in the 1950s and 60s, we had not yet been to Mars with spacecraft. And so when I would look at the planet through my telescope in my backyard in California, it would look like that. And I'd say, man, I wonder what the surface of Mars is really like. What's it really like on Mars? Meanwhile, a few hundred miles away on Mount Palomar with the giant Hale 5-meter telescope, largest telescope in the world, there's some astronomer looking at pictures from Mars taken with that telescope and saying, man, this looks like an interesting place. I wonder what it's like on the surface of Mars. Back then, what I thought about Mars and what professionals thought about Mars, it was kind of the same. We were kind of on the same wavelength. Now it's very different. We know all about Mars, and when I see Mars, it still looks like this through my telescope, but we know it a lot better. This is what Mars looks like through the Hubble Space Telescope. And those bright and dark markings come into a little bit sharper detail. It turns out that these dark markings are mostly lava flows. And the bright markings are mostly areas of light-colored sand. But we didn't know that then. And it's really hard to imagine that even with this picture. It wasn't really until we could go to Mars and see it through the eyes of spacecraft that we got a really good idea of what Mars was like. But that was really late in the game. Well, I'm going to take it back in time. I'll kind of show you Mars circling, and you see all these sort of enigmatic bright and dark features. It's really kind of an interesting place. We're going to take it back in time to the late 1800s. And there were two astronomers who were really on the cutting edge of exploring Mars. Giovanni Schiaparelli, who was Italian, you'd never know from his name, and Percival Lowell, our own Percival Lowell, born and bred here in Boston, rich family. Lowell the city of Lowell is named after him. He became a self-taught astronomer who became captivated with Mars, and with his money he went out to Arizona and built an observatory in Flagstaff with state-of-the-art telescopes. It's called Lowell Observatory still to this day. Now, Schiaparelli had, this was before the age of photography. So in those days, when an astronomer wanted to record what they were seeing through the telescope, what do you think they did? They drew pictures. They did sketches. And so Schiaparelli was interested in Mars. And you need to understand a little bit about the orbit of Mars and the Earth. The Earth has an orbit that is shown in blue here that's almost purely a circle. The P stands for perihelion, when Earth is closest to the sun, and the A stands for aphelion, when Earth is farthest from the sun. Now here we are in the middle of July. What do you think we are? Do we think we're closest to the sun or farthest away? Who thinks farthest? Who thinks closest? All right, there's some people here who did not vote. Closest to the sun, farthest away. I mixed it up for you. All right, we are farthest from the sun right now. Right, we're actually closest in January. Don't forget, it's summer for us, but it's winter for the Australians. Now, Mars, by contrast, has an orbit that's not so circular. It's quite a bit more eccentric or elliptical. And so there's a point at its perihelion, it's a lot closer to the sun by tens of millions of miles than it is when it's farthest away. This becomes important because in 1877, there was an especially close pairing of Earth and Mars together in their orbits. Because Mars goes around every 2.2 years, and Earth goes in 1 year, every once in a while we pass Mars close, we lap it, right? In 1877, we did that, and Mars happened to be at an especially close point in its orbit to the sun, and therefore to Earth. So it was especially close to Earth. We call that, in astronomy lingo, a perihelic opposition. And so Giovanni Schiaparelli was taking sketches of Mars through his telescope like crazy every night that he could, And he ended up with this map. This is kind of like a Mercator map, you know, with the poles at the top and the bottom, and the equator runs through the center. Right? And look at all this interesting detail he saw. Much more than what I showed you in that telescopic image. He saw big white blobs and dark fingers connecting them. And he called those fingers canali, which in Italian means channels. Now, if I were to say to you, I just crossed the channel, you might think, okay, I took the ferry to Nantucket, or I crossed the English Channel, but it got translated into English as canals. Canali became canals. Canals have a very different interpretation. We think of those as being human, man-made objects. So Lowell, reading of these reports of Schiaparelli's canali on Mars, said, I got to get in on this action. And so Lowell, using his telescopes, studied Mars, and he was looking for canals, and sure enough, he found them. Lots of them. These are some maps from Percival Lowell. You see his initials down here. He had this notion of oases with fingers connecting them that were the canali. You know, this kind of makes sense. We knew Mars was far from the sun, but it was still relatively warm. And we knew about the polar caps, and the polar caps got big during the winter, and they shrank during the summer. And the notion was that the polar caps, of course, were made of water ice, and when the water ice melted, the Martians, desperate for water at the equator, would build these canals to bring water from the melting polar caps to irrigate their crops near the equator. And in fact, there was some sense that these dark areas got bigger and darker during the local summer, like crops growing. Well, we didn't know. We couldn't prove it. By the late 1800s, this is what our notion of Mars was, a veritable superhighway of crisscrossing canali. This is like the Los Angeles freeway map, you know? And so, was this real or was it imaginary? Well, people became so convinced that Martians had built these canals that the French Academy of Sciences in the year 1900 offered a prize of 100,000 francs, which was a lot of money now. And you can imagine 100,000 francs back in 1900, that was really a sum, quite a sum, for anyone who could establish communication with an alien civilization, except for Mars, because that was considered too easy. Well, this was our notion of what Mars was like. Canals built by the intelligent Martians who were channeling all this water. This is a painting by a famous astronomy artist named Chesley Bonestell. Now here's the thing. We see Mars through our atmosphere. We have to look out through our atmosphere. And our atmosphere creates a lot of turbulence in the view that we see through our telescopes. And it causes blurring. And if you're patient enough, every now and then, the blurring will stop momentarily and you'll get suddenly a very clear view of whatever you're looking at, be it a planet or a galaxy. We call this seeing. And actually, the seeing is a lot more stable in the summertime than it is in winter. And so the problem, and so this is what the basis on which Schiaparelli and Lowell did these maps. But these are photographs of Mars taken at around the turn of the century, about a century ago. And do you see lines of crisscrossing canals? They're just not there. Now back then they couldn't do this, but today we can. We can take all these images and electronically combine them to improve the signal to noise of what they showed. Because you can see they all sort of were taken at the same time. This one down here looks a little bit sharper than this one up here in the corner. And so you take all these images and you combine them together, and this is what you get. This is an actual combination of photographs, and this is one of Lowell's drawings. Now look. Why, look, here's a finger down here, and it kind of splits. Here's a finger, and it kind of splits. Here's a big circle with lines around it. Here's a big circle with lines around it. Here's another one. Right? Look at this. Here's two spots with lines drawn between them. Two spots. Big circle here with things radiating away. little finger coming down here. Maybe the canals are real. So into the 1960s, many astronomers believed that, maybe they didn't believe in the canals, but this notion of the planet getting darker during spring and a wave of darkening as the polar cap shrank, people thought there was life on Mars. Now maybe it's just, microbes, or maybe it's just vegetation. The consensus was that there was life on Mars. We couldn't tell. We couldn't prove it. So we needed to wait until spacecraft went by. In the beginning of the 1960s, when our space program got started, we were finally able to have rockets and spacecraft powerful enough to get to Mars, and they were going to show us these big fields of verdant, green, whatever. This was the first picture from Mars taken by a crude television camera on Mariner 4 in 1965. Remember the name Mariner, will come up later. Look like the Earth? Not really. Looks like the moon, right? Boy, was that a bummer. Very great disappointment. Now the interesting thing is that Mariner 4 flew by Mars on July 4th, 1965, and exactly 50 years later, New Horizons, to the day, flew by Pluto, arguably the most distant planet in our solar system. What a wonderful coincidental pair of bookends of planetary exploration, our first views of Mars and our first views of distant Pluto. Well, okay, so we went back to Mars again a little bit later, a couple of years later, with even better spacecraft, two of them this time, Mariner 6 and 7. And in 1969, they returned pictures that looked like the moon, not like Earth at all. Double bummer. Okay, so what were we doing wrong? What was wrong with our notion of what Mars was like? Well, we were going to send an even better spacecraft called Mariner 9 to arrive at Mars and actually go into orbit. These earlier spacecraft just kind of flew by really quickly. They only had a couple of hours to take pictures. They couldn't photograph the whole planet. They could only photograph the part that was facing them as they whizzed by at 10 or 15 miles per second. So in 1971, we had a spacecraft that was going to go into orbit around Mars, but something happened. I told you about its very thin atmosphere, right? 100th the density of Earth's atmosphere. But even that is enough when the winds whip up on those hot summer days to stir up the very fine dust, almost like talcum powder on the surface of Mars, and create not just a local dust storm, but a global dust storm, right? Imagine, they're having a really hot time in Arizona right now. Imagine if the winds whipped up the dust so much in Arizona that it covered the United States. That would be bad. But this is what happens on Mars. This is a dust storm in around the year 2001. This is what it normally looks like to the Hubble telescope, and this is what it looked like after the dust storm settled. This is what happened in 1971. Just as Mariner 9 was approaching the planet, a terrible dust storm arose that covered everything tens of miles deep in dust. This was and so it was a blank canvas. And gradually, but it went into orbit successfully, and we could wait it out. Gradually, the dust settled. This was one of the first things to show up. It's a cluster of craters, pretty obviously, except given how deep the dust is, this must have been about 15 miles high above the surface. How can that possibly be? We soon came to realize exactly what was going on. The dust cleared, and one of the amazing things that we discovered now that we could look at the whole planet is that there was evidence all over the place that water had flowed on the surface of Mars. We had rivers, complicated river networks, what we call dendritic patterns. Here's another one. Here's a thicker river, right? This is probably called by a process created by what's called sapping. The rain doesn't actually fall. It kind of like oozes out of the ground and creates these river systems. Here's an amazing, there's a lot of water involved here. More water than was at the poles. So the surface was telling us that there was a lot of water on Mars. The poles, the ice at the poles was telling us that there's some. So where did all the water go? Where it wasn't on the surface now, it's too dry now. Here's a place where a whole chunk of ground collapsed. You can see all the rubble in the bottom making a canyon. And there must have been water underground that was released in a giant flood that flowed across the surface and carved all this landscape. Amazing. Well, I told you about the atmosphere, right? The atmosphere creates clouds. And I told you what the clouds on Mars are made of. Who remembers? Water, okay. These are water ice clouds, and they're stuck over these spots on the ground. They were actually mountains. We have this on Earth. They're called orographic clouds. On Earth, clouds often form at the summit and on the leeward, the anti-windward side of a mountaintop. And that's what was going on here. This feature up here was so persistent we could see it from our telescopes on Earth. It was called Nix Olympica, the snows of Olympus. We didn't know that there was a mountain there, but Mariner 9 showed us that there was a large mountain there, and in fact a mountain here, here, and here, really gigantic mountains. Here's that Nix Olympica, the actual mountain, now called Olympus Mons. Mons is the Latin word for mountain. And here's that cluster of craters that was jutting up into the clouds. This is a mountain that's 15 miles tall, 3 times taller than Mount Everest. And it's a really big mountain. And this is where you say, how big is it, Kelly? How big is it, Kelly? Thank you. I thought you were going to, and never thought you'd ask. It's as big as the state of Arizona. It's an enormous mountain. It's 400, 500 miles across. And this was one of like 4 or 5 mountains on the surface of Mars. And there are other things too. Here's that Hubble image, and you see this big circle. This is a big impact basin. Here it is, seen in some detail. It's called Hellas Planitia. It's an enormous impact. It's a really big impact. I thought you'd never ask. It's mostly the size of the United States. It's about 1,500 miles across. It's the largest known impact crater in the solar system. It had to have been a pretty good-sized object, a couple of 100 miles across, to hit Mars and leave a hole that big. And then we saw this gigantic canyon system that stretched along the equator. Here are some of those mountains sticking up over here on the edge. You can see some of the river systems here. This is a really, really, really big canyon system. How big is it? Well, I'm glad you asked because it's 2,500 miles long. It was stretched from one side of the U.S. to the other, the continental U.S. It's 120 miles wide at its widest, 7 miles deep. At this scale, this is about the size of the Grand Canyon right here. Right. Remember, Mars has all the surface area that the Earth does. And we were delighted to find out that it has this varied geology. It has these dry riverbeds, which are amazing in and of themselves. It has canyon systems and mountains and faults and all kinds of interesting things. Now here's a map of Mars from all that data, and the color shows altitude. It's a topographic map. The whites and reds are the highest areas. So here are those three giant volcanoes. Here's Olympus Mons. Here's an even bigger one called Alba Patera. Here's Hellas Planitia down here. What I want you to notice is that in the southern, so this is a Mercator map. Here's the equator running across here. Here's the North Pole, and here's the South Pole. I want you to notice that the southern half of Mars has a lot of craters on it, right? Now in the solar system, we figure out roughly how old something is based on how many craters it has. Especially if it doesn't have an atmosphere, like the moon, right? If you look at the moon, you see an area with a lot of craters, that means that surface is really old because it's been pelted with asteroids for billions of years. If you see an area that doesn't have many craters and is smooth, that means it's got to be a relatively young surface. Something has wiped the surface clean of all the pre-existing craters, and the counting starts over again. Look at the northern hemisphere of Mars. Not very many craters, and because of the color, the blue color, meaning it's low in altitude. It's low in altitude, doesn't have many craters. The blue is suggesting, well, it's an ocean. Of course, there's no liquid water there now. But it begs the question, could there have been an ocean in the northern half of Mars early in its history? We want to find out. This is looking down on the pole. Here's the polar cap. And you can see this, again, this is graded according to altitude. This is a giant depression in the northern half of Mars that's flat. Now we now know that most of this area is covered with lava flows. That's why it's so young. And that's why it's so flat. It's not some big giant seafloor sediment. It's actually lava flow. So how did the lava get here? Well, that's a good question. We think, scientists think, that maybe early in Mars history, if you thought Hellas Planitia was big, maybe there was an even bigger impact that slammed in the North Pole of Mars, right? And created this ginormous impact that left a huge depression where the North Pole of Mars is today. Now that's just a guess. It's what we call a hypothesis in science. But we have a little bit of data to suggest that's really the case. So this is a plot, a slice through Mars showing its crust. The North Pole's over here, the South Pole's over here. What I want you to notice is that the crust is thinner under this northern region. And that kind of makes sense if you think about it. If I slam into Mars with a big thing, right, I'm going to throw a lot of stuff out from the northern half and it's going to end up on the southern half. So it makes sense that the crust on Mars would be thicker in the south and thinner in the north if the impact really took place. We don't know. It's just a guess. We still don't have any proof. It's just a hypothesis. Well, here's one of those polar caps. Very interesting feature, made mostly of water ice. This is what we call the permanent cap. This is what you would see in summertime. Because even in summertime, it's so cold on Mars that water ice is perfectly happy being frozen. In wintertime, it gets so cold that the carbon dioxide can freeze out and create a larger polar cap of dry ice, right? We call it dry ice, frozen carbon dioxide. That's even bigger. Well, I mentioned that there was so much water evidenced by all those channels cut into the surface. Where did all the water go? It's not in the polar caps. We have a way, using spacecraft, to kind of indirectly figure out where there might be water buried as ice on Mars. It has to do with the hydrogen that's in water. And so this is essentially a map of hydrogen abundance on Mars. And you notice that the blue areas, which is where there's most of it, are in the polar regions. This, we think, is where there's buried ice. Lots and lots of buried ice. And not very far below the surface, because this technique is only good to about 10 feet deep, and then it becomes insensitive. So if there is water on Mars, this is where we think it is. Remember this map. We'll come back to this later. One last thing I want to mention to just complete our inventory of Mars. Mars has two small satellites. The largest, Phobos, is only about 15 miles across. These were also discovered in 1877, when Mars and the Earth were especially close. They were discovered at the U.S. Naval Observatory in Washington. Little known fact, the Naval Observatory in Washington is where the residence of the Vice President is. So it's where Vice President Mike Pence and his family live right now. He doesn't make many trips to the observatory, but his predecessor, Joe Biden, and Jill Biden, who herself was an educator, went there often to look through the telescopes at the observatory. Okay, now they're small, nothing like our moon, and Phobos is the inner one. That's the larger one. It goes around Mars in just 8 hours, less than 8 hours, whereas the planet itself turns in about 25 hours. That's important, and here's why. On the Earth, we have this thing called an ocean. And the ocean is attracted by the moon's gravity, and it creates a high tide, right, and a low tide. There's 2 high tides and 2 low tides at any given time on the Earth. The moon is attracting the ocean and creating a bulge on the Earth that represents high tide. But because the Earth is spinning fast, relatively fast, the moon takes a month to go around the Earth. Moon, month, there's a connection. The Earth is spinning so fast that the tidal bulge is not along the Earth-Moon line where you think it might be. It's actually offset a little bit. That's important because this tidal bulge pulls on the moon, and the moon pulls on this tidal bulge, and there are consequences. But before I tell you what those are, let's have another quiz. If there were no moon, would we have tides? Who says yes? Who says no? One more time. Who says yes? Who says no? Oh, you know, folks? You're wrong. We would still have tides because the sun would create tides. But the moon is the most dominant. It creates about 2/3 of the tides in our ocean. Okay, so what happens is that over time, the moon attracts this tidal bulge and it drags the Earth's rotation down a little bit. The Earth's rotation is slowing down. by a hundredth of a second every century. Not very much indeed. You no need to reset your clocks because of it, okay? Not very much, but over millions of years it does make a difference. And conversely, that energy is being transferred to the moon, and the moon is moving farther out in its orbit by about this much every year. Every year the moon moves that much farther away from the Earth. There will come a time, about 1 billion years from now, when we can no longer have total eclipses of the sun because the moon will be too far away to cover the sun completely in the sky. Okay, remember this. Earth spins faster than the moon goes around. On Mars, it's the opposite case. Mars spins a lot slower than Phobos goes around, and the gravitational pulls are just in the opposite direction. Mars is actually dragging Phobos closer to it day by day, and within 1 billion years or so, Phobos will crash into Mars. And I want to be there when that happens. Okay, a few pretty pictures for you. This is a close-up of that polar cap. The poles create layers, almost like tree rings, because the climate of Mars goes through these long-term cycles, kind of like ice ages on Earth. You know, we have ice ages every tens of thousands of years. And on Mars, the climate changes on these long time scales, and dusty deposits build up and then get torn away, build up, torn away, kind of like tree rings. This is a close-up of the edge of the polar cap. This is also in the polar cap. The white stuff is a frost of carbon dioxide, which has been warmed by the sun, and it's starting to vaporize away into the atmosphere, and it leaves behind these kind of cool-looking spidery patterns. Very neat. There are sand dunes on Mars that move across. The atmosphere is not very dense, but it's enough. There's wind, and it kind of moves around these little particles and creates sand dunes. This is the top of a cliff. This is the bottom of the cliff, and this is a landslide caught in the act going down the cliff on Mars. We have spacecraft that can take pictures. They're taking pictures all the time. We'll get to that in a while. Amazing picture. This is a dust devil. The white thing is kind of like a dust devil on the surface of Mars, a whirlwind that is traveling across. You can see the white. The black area is not the shadow. It's the place that the dust devil has scoured across the countryside and removed all the light-colored dust that happens to be lying on top and scouring it clean. So it's actually moving in this direction. Very cool. Finally, I'm going to show you this. This is the inside of a crater rim. And these are gullies that are cascading down the slope. And they change. We've seen them change. They get bigger. They get longer. We don't know if that's caused by a trickle of water, little rock slides, Martians with a trowel, you know. We don't know exactly what's causing these, but we do know that they're happening now. They're forming now. And then finally, this is a golden oldie. There's a little feature here. This was a picture taken by Viking 1 back in 1976. And I covered the Viking mission. It was in an area called Cydonia. And when NASA released this picture, it said, haha, look at that. There's a little landform there that looks like a face. A face! People thought, there must be Martians. This is what it looks like close up. Those Martians are very smart. They know what humans look like, and they have carved a mountain, kind of like Mount Rushmore, to look like a human face so we'll know they're there. And people believe this so much so. We didn't send any spacecraft to Mars after the Vikings for more than 20 years. It was a conspiracy. NASA didn't want us to know what they knew, which is that the Martians are there and they're waiting for us. Well, come on. Really? What it really is just a beat up little tabletop mesa with all kinds of, and the lighting was just right. The lighting here has been taken to kind of duplicate what Vikings saw, right? Here's the eye socket, and here's the sort of crown, and it really is just a piece of chewed up Martian real estate. Thank goodness that has gone to us. I mean, there were people who, they were like on AM all-night talk radio every night talking about this. Okay, so let's talk about going to Mars and landing on it. We've now gone to Mars quite a few times with our landers. The Vikings were in the mid-1970s, Pathfinder 97, Spirit and Opportunity in 2004, Curiosity is there now, Phoenix was in 2008. And I want you to notice Mars 3 down here. If you ask people like me who know something about astronomy, what was the first spacecraft to land on Mars, 99 out of 100 of them will say Viking 1 on July 20th, 1976, sorry. And I would submit to you that that is not correct. In 1971, remember that was the year of the big dust storm when Mariner 9 arrived. The Russians, the Soviet Union at that time, sent a pair of spacecraft, including landers, to Mars. One of them was Mars 3. It looks like this, right? It opened up, it landed, it opened up, raised its radio transmitter, and sent 20 seconds of signal to Earth. The fact that it sent those signals meant that it must have landed successfully. That's the only way it could have worked. And then nothing. No pictures, no more data, it just went silent. And we think what happened was it landed in the middle of that terrific dust storm, and it just got flipped over, right? Later, we've actually now, using our current technology, we've taken pictures of the Mars 3 landing site. There's the lander, its retrorocket, its parachute. They're all there, right? We know where it landed now. And so that was the first, to my mind, the first successful landing. The first landing that actually did what it was supposed to do was, in fact, Viking 1. This is a picture of the Martian surface taken by Viking 1. And the first thing that you see is, it looks like Arizona. Doesn't it? Rocky, sandy, sun-bleached, right? You could absolutely imagine yourself walking across that landscape. And so 21 years later, we went back with another lander. This time it included a little rover called Sojourner, named for Sojourner Truth, the female abolitionist. And Sojourner could sample the rocks and move around. It lasted for a while. And so now that we have these spacecraft on Mars, I think it's time that we go to Mars too. Now's the time. I want you to please put on your 3D glasses. Let's start. You should see a 3D view of a spacecraft called Mars Odyssey. You seeing a 3D view there? You see, this is the arm sticking out. This is the part in front. This is sticking back in the eye. And here's Mars. You should see that behind everything. If you're not seeing that, that means that your head exploded. This should be easier. This is a crater. The crater formed, and then these cracks formed later, cutting through the crater rim. Now, if you're still having trouble, this should be a piece of cake. Okay? This is the entrance to the cave in Thailand. Where no. What a great story that is, huh? No, this is it's actually, this 3D perspective kind of exaggerates the actual depths. But this is a nice deep crater. This is a series of craters that have formed when the ground cracked underneath and the topsoil fell in. Created a series of craters. This is a landslide from up here on top, down into the canyon. You see this big tongue of debris cascading down the slide. This is one of those floodplains, and you can see that the water was flowing so torrentially that it literally carved into the landscape. There are really only a few places on the Earth where we've had floods that torrential, that gigantic, to literally tear up the landscape. Okay, so here's a picture from Mars Pathfinder. And what I want you to do is take off the glasses for a second. I want you to study this image really carefully, right? Yeah, you can see some rocks, and yeah, there's a distant thing here, but in between is kind of boring, right? Now put the glasses back on. Oh, look, there's a little ledge right here. There's another ledge right along here, right? And there's kind of a depression beyond it right there. Can you all see that? This stereo stuff is not just a gimmick. It's telling the scientists real science. And so the landers come with two cameras, like two eyes, and they take two pictures, and when they combine them, we get these stereo images. Here's from Mars Pathfinder. There's the little rover. Headed, its first target was this rock over here, which was nicknamed Yogi. Yes, it was nicknamed for Yogi Bear. There was a Boo-Boo. There was also a Wallace and Gromit, Fred and Wilma, Barney and Dino. We nickname these rocks because we need to figure out, remember one from the other. Okay, so our next rovers landed in 2004. It was a pair of them, Spirit and Opportunity. They landed a couple weeks apart. Here's Spirit leaving its sort of landing pad and heading off. You can see it's a fairly boring terrain, but you can see there's kind of a ridge here, right, and flatter area out there. You can see some rocks. This is really great for looking at rocks. These rocks appear to be made of a mineral, an iron oxide mineral called goethite, which has to form somehow in the presence of water. It's an iron oxide, and the oxygen comes from water. By the way, we call Mars the red planet. And the reason it's red is because its rocks are rusty, literally. The surface of Mars is full of iron oxide, and that's what gives it its red color. Well, here's another picture from Spirit showing some beautiful bedded terrain. This is probably stuff that was laid down by wind over time as opposed to water. However, late in its mission, Spirit, these rovers have 6 wheels. And Spirit lost the use of one of its wheels, one of its rear wheels. And so as it's trundling across the landscape, it's kind of dragging this wheel behind it. And that wheel dredged up some deposits that were just below the surface, that were rich in salts. Now on Earth, a geologist would tell you, if you see a lot of salts, there had to have been water there. So we're looking for water in all of its different evidence. On the other side of Mars, Opportunity landed, and the first thing, it actually landed inside a little crater. And the first thing it saw as it looked out were these little pebbles all over the place. Look at them all. They're colored, kind of colored blue here. The color here is exaggerated a little bit, but the color is real. They're blue, and they're about the size of a berry, and so they got nicknamed blueberries. And what these are little concretions of another kind of iron oxide called hematite. Now, some of you have heard of hematite jewelry, right? But in this case, the fact that they're little round blobs of hematite meant that they had to form not only in the presence of water, but in water. There had to, in this location on Mars, there had to have been, at some point in its past, standing water for a while. A lake, a flowing river, whatever. Well, Opportunity was a very ambitious little rover, and so it started off here, landed in Eagle Crater. The scientist said, I wonder if we can make it down to here, because this is like a fresh crater and we can really learn a lot. The scale down here is, this is about a half a mile. And so it set off. You can see the time points here. It landed in 2004. 2.5 years later, it had made it down to, it took 2.5 years to get down here. Here are some of the things it saw along the way. A smaller crater called Endurance with some sand dunes in the bottom of it. These are the trails across the sand. A lot of boring stretches. This is actually good terrain because, we can't drive these rovers in real time. The radio time it takes the radio signals to travel, even at the speed of light, is like an hour round trip, even at its best. So what they would do is they would load a lot of commands into the rover and say, okay, we think this direction is safe. Drive here for 100 yards and stop and report back. Well, when they got on stuff like this, they could say, just go, right? And it could cover a lot of territory. So here's that crater, sand dunes at the bottom, Victoria Crater. It's about a half a mile across, very comparable in size to Meteor Crater in Arizona. Anybody ever been to Meteor Crater? It's a terrific place. The rest of you, put it on your bucket list. It's a place where a big chunk of iron meteorite, roughly the size of this library, slammed into Arizona about 50,000 years ago and left a crater a half a mile wide. You can walk around it, you can walk in it. It's really a great thing to do. Anyway, so here we're going to focus on this little spot here and blow it up. seen from orbit, that's where the photo was taken. Here is Opportunity on the rim of the crater. And if you look closely, you can see the tracks of the rover from orbit as it approached the crater rim. Well, this is what the crater actually looked like, as seen from Opportunity. A very rugged rim. And you can see the bedding in it. This told scientists lots about the history of this part of Mars. Along the way, it passed an iron meteorite, and they nicknamed the meteorites just like all the other rocks. This one they nicknamed Block Island, near and dear to us, right, here in New England. And unlike the Earth, when a meteorite falls on the Earth, it has borrowed time. Because first of all, it could land in the ocean, right? It could land in a heavily forested area. No one would ever find it. There's wind, there's water, there's rain, there's snow, there's mud season. And meteorites tend to weather away pretty quickly on Earth, but not so on Mars. They stick around for a long time. Okay, so that's Spirit and Opportunity. In 2008, remember the map that showed all the blue at the top and the bottom, right? That's where the ice supposedly is. NASA sent a spacecraft to Mars to land in the polar region, Phoenix, in 2008. And it was not a rover. Its job was to sample the ice. That was its big task. So it didn't have wheels, but it had this really long arm, and there's a camera at the end and a claw, right? Its job was to grab some stuff, maybe find some ice, and then dump it into experiments that had hoppers here on the top, and it would go inside and they would just analyze the composition. Well, right after it landed, this is what it looked like. Pretty boring, right? Even in 3D, it's pretty boring. Kind of a gently hummocky rolling. That's actually very diagnostic. It looks a lot like what we see on Earth in areas where the ground is permanently frozen, like in northern Canada or Siberia. Right? This is a very diagnostic of frozen, water-saturated ground. And scientists went, ooh, okay, maybe we found something here. So then they took that arm and they reached over and looked underneath to see what was underneath the lander. The lander had used rockets to fire just before it landed to slow its speed. And the rockets kind of scoured the ground right underneath the landing site. Lo and behold, they found a huge slab of ice, solid ice, just a few inches below the surface that had been blown clean by the rocket blast. They had literally landed on a dust-covered glacier with this spacecraft. Aha! Now we're going to get to sample the ice. So they started trenching, dug some trenches, right? And it hit solid ice almost immediately. And it kept scratching and scratching and scratching. You know what it's like to try to carve an ice cube with a fork? It takes a long time, and so it kept doing this, and it finally got like a clump, like a snow cone, right? And it put it on top into the instrument hopper. And the instrument hopper had a screen on it to keep the rocks out. And when they put this ground up ice on top of the screen, it kind of went plop and didn't go through. Kind of like trying to push snow through a window screen. It just doesn't happen. And so in that sense, Phoenix actually did not accomplish its mission. We never did get an analysis of the ice, of the water ice that was there. So much of it, right? I think there's a famous line, water, water everywhere and not a drop to drink. Right? And that's kind of how Phoenix was when it couldn't sample this. Okay, well, let's fast forward to sort of the current day. And this was Sojourner. These were a Spirit and Opportunity. This is the 500-pound gorilla of Rovers, the latest model. Right? It's got lane avoidance technology and automatic cruise control, braking and stuff. It's actually powered right here. There's a big chunk of plutonium as a plutonium dioxide kind of embedded in a ceramic glass. And that, as it decays, the radioactivity decays, it gives off heat that the spacecraft converts into electricity. So unlike these other rovers, which had to collect sunlight in order to be powered, Curiosity brings its own. And this is what it looks like in 3D. This is at the Jet Propulsion Laboratory. You can see the 6 wheels here. There's a big mast, and on the mast are 2 cameras. a telephoto lens and a wide-angle lens. And up here is a laser, powerful laser, that can zap the ground, right, and heat the ground, little spots on the ground, to a couple of thousand degrees so that the ground literally vaporizes and creates a white-hot puff of vapor. And then instruments on the rover could be like from here to that wall. I can sense that vapor and I can analyze the gas and figure out what the rock was made of, even if I'm not even touching it. That's a great idea. It landed on the surface using this very elaborate contraption. Some of you may have seen the NASA video called 7 Minutes of Terror. That's what this was all about. I am not going to show you that. I'm going to show you where it landed. It landed in a big crater about 100 miles across called Gale Crater. Gale was not a world-famous astronomer. He wasn't. He was a banker in Australia who happened to be a very avid amateur astronomer, and they named this crater after him. And the reason they wanted to land in Gale, because the floor was flat, which made it nice and safe, but also you can see these rivers that kind of flow into it, a couple of places along the... We think that at one point there had to have been a lake inside Gale Crater, which is great, because if you're looking for interesting things to study, you want to be where the water has been before. And the other thing that was interesting is this really tall mountain. Again, we're using color to indicate altitude here. This tall mountain that's in the middle of Gale Crater. That mountain is really what the mission is all about. So Curiosity, so this was its landing oval. This was its target area, right? And here's that target area sort of seen obliquely in a kind of artistic rendering. And the job of Curiosity was to crawl its way up the mountain slope and sample along the way. Sample the rocks and find out what the composition of the rocks is. Now, you know the Grand Canyon has a lot of layers in it, right? And the oldest ones are at the bottom and the youngest ones are at the top. When those rivers flowed on Mars to carve all that landscape, it must have been 2 or 3 billion years ago, maybe 4 billion years ago. Back then, Mars obviously had water, liquid water on its surface. And in order to have that, it had to have had a thicker atmosphere. Liquid water, thicker atmosphere, warmer temperatures, pretty nice place to take your vacation, I think. But then something happened. Between then and now, Mars changed very radically. The atmosphere got very thin. The temperature got very cold. The soil chemistry changed and made it very harsh and noxious and not very conducive to life at all. And geologists want to know, what the heck happened to Mars? What happened between billions of years ago when it was a pretty nice place and now when it's just this bleak place that only Matt Damon can live on, right? In the Martian. Okay, so that was Curiosity's job. Here's its landing. You can see this is a 3D view. It's landing on this really nice flat spot right where it's supposed to. This is the mountain in the center. The mountain has a technical name, Olympus Mons. Again, that word Mons meaning mountain. But its nickname is Mount Sharp, named for a geologist named Robert Sharp, who was a planetary geologist. He was a pioneer in the notion of using geology to study the other planets. He taught at Caltech. I was lucky enough to take a class from him when I was there. He got me on the path to where I am today. Otherwise, I could have been, surfing in California or something instead. Anyway, Mount Sharp, named for him. See, this is a close-up. See the layers? Right? This is Martian history laid bare to study. And that's why Curiosity landed here. Well, it was going to go up the slope, but it found so many interesting things right around where it landed. This, for example, is an outcrop. And look at all this interesting pebbly stuff going on in this slab of rock. One of these pictures is a picture of that rock. And one of them is a picture of the Earth. These are both what we call stream bed conglomerates. These are pebbles that are loosely cemented together by silt and other stuff in the bottom of a flowing stream. Where Curiosity landed, there had been flowing water in the bottom of that crater. Exactly what they had hoped for. So this is a 3D image. This is its target, getting up the slope of Mars. And this has nothing to do with what I've been talking about. This is a 3D image of Phobos, one of those satellites taken by a European spacecraft called Mars Express. And it's just kind of cool to look at, right? And you see all these like little strings of craters here? These are actually fractures. This is a big crater named Stickney. Stickney is the wife of the astronomer who discovered Phobos. Her maiden name was Stickney. Circle of life, right? It all comes back. Anyway, when this crater was formed, it sent such a shock through Phobos that it fractured it. And that's what these cracks are. OK. I'm sorry, the 3D show is over. You can just hang on to those for a minute. OK, so here's Curiosity. It landed a place. Its landing site is actually known as Bradbury Landing. Ray Bradbury, the famous science fiction writer. Here's my story of Ray Bradbury. I was working at Caltech for a planetary geologist, not Robert Sharp, another one named Bruce Murray. And Bruce invited Ray Bradbury, who lived in Los Angeles, to come and give a lecture. Except Ray Bradbury didn't drive. And to his death, he didn't like to fly either. So I, the undergraduate lackey, had to go pick up Ray Bradbury, bring him to the lecture, and take him home afterward. Right? In my 62 Bonneville convertible. Powder blue. And I had Ray Bradbury, one of the world's most renowned science fiction writers, all to myself for a couple of hours. There's a longer story there, but I'll leave that to tantalize you. Anyway, Curiosity took its time. It's finally making its way. The mountain is down here at the bottom of the picture. This is it took time to make a selfie with the mountain in the background. You know, it's got an arm with a camera on the end, and it kind of takes. And they take a bunch of pictures, and then they Photoshop out the arm, right? Because the arm would be in the way otherwise. It's making its way. You can see the time tags here, 2015. It landed in August of 2012, 6 years ago. And it's taken, you can see it's gone 8 miles in 3.5 years. And finally, it's really making its way up. And it's moving between, I'll take the last one here. The clays are down, lower down. Clays are a very nice, benign kind of mineral that you get when you have water erode rock. You get clays. It's all kind of neutral. But sulfates are kind of an noxious kind of water product. And the difference between here and here is everything about the change of Martian climate and its evolution. This is kind of an incidental thing. Curiosity has a drill. I mentioned that the rocks on Mars were rusty. That's only a skin deep kind of thing. If you really want to know what the rocks are made of, you don't want to be sampling rust all the time, right? So you want to drill down to get to the actual rock and analyze that. So Curiosity has a drill. And it was offline for about 1.5 years. And just about 2 months ago, they finally got it working again. And so now it's back in business. OK, so where we stand. Great. This is a great trivia question for your next party to prove your inner geek. All right? We have right now 5 spacecraft in orbit taking data about Mars. Who would have guessed that there are that many? Right? Maybe 1 or 2, 5. And they're not all NASA's either. I mentioned the one from the European Space Agency, which is kind of like the European Union's space program. And even India has an orbiter around Mars right now. We haven't heard too much from it, but it did arrive and it does work. And we have 2 rovers, Opportunity, which landed 14.5 years ago and is still going strong. It was only supposed to last for 90 days, right? And it's still going. Spirit, unfortunately, froze to death, no more. Curiosity, it's built for the long haul. We expect Curiosity to last at least 10 years. And we have another spacecraft on its way to Mars right now. And you'll hear about it more later this year. It's called InSight. And it was launched back in May from California. The first time ever that an interplanetary spacecraft had been launched by the United States in California, as opposed to Kennedy Space Center in Florida. And there's a whole story there for that. I went out for that launch. InSight is a very clever name. It's what we might call a backronym. It's like an acronym. They started with this clever name, InSight. Ooh, that sounds good. Now let's make up the words that would make InSight as an acronym. The interior exploration using seismic investigations, geodesy, and heat transport. Right? I just call it InSight because I can't remember the rest of this stuff. Well, here was the launch of InSight back on May 5th. And you can see it's pretty foggy. This is a camera right at the base of the spacecraft, right? You can see all the glare and the lights. Here's the launch. I'm 3 miles away.
Robotic explorer to study the interior of Mars.
And it rises into the clouds, and it's gone.
Interplanetary mission on the West Coast. And NASA's InSight, the first outer space robotic explorer to study the interior of Mars.
I was 3 miles away. I saw nothing. Not a glow. I heard it, right? There wasn't like a bright blip. Nope. Because I knew what to look for. The clouds kind of got a little bit lighter. It was also 4 in the morning. Can you imagine? Fly all the way out to the West Coast, leave my wife in the hotel room, drive onto this, Department of Defense site, go through all these checkpoints, guard dogs sniffing all around me and everything. Set up 4 in the morning, can't find nearly enough coffee to stay awake, and then not get to see it. But anyway, all right, so it's headed for here, and the location has been chosen to be as boring as possible. It has a camera, and it will show us what the landing site looks like, but looking around is not what InSight is all about. Its job is something very, very different, as you'll learn right now.
Shortly after landing, InSight's robotic arm will lift the seismometer and heat probe from its deck and place them on the surface. A camera on the arm will show a color 3D view of the landing site. Sensors will measure weather and magnetic field variations. And then the real work begins. The heat probe will burrow itself into the crust millimeters at a time until it reaches a depth of about 16 feet or 5 meters, and then measure how warm the interior is and how much heat is flowing through the planet. The seismometer, on the other hand, will measure the tectonic activity on the planet. Just how many, not earthquakes, but Marsquakes, are produced over time? How powerful are they? Do they have a pattern, or are they randomly located? When a quake occurs on a planet, it releases waves of energy that bounce throughout the interior of that planet. The waves travel at different velocities depending on the geologic material they travel through, and if the waves travel along the surface or deep into the planet. InSight seismometers will measure the size, frequency, and speed of these waves, giving scientists a snapshot of the material they pass through.
Okay, so InSight's job is to study the interior of Mars in a way that we've not been able to do so far. On Earth, when there is an earthquake, say in Indonesia, there are seismometers all around the planet that can pinpoint where that earthquake occurred with incredible accuracy because the waves propagate, and a seismometer that's closer records it sooner, and one that's farther away records it later. In the case of InSight, it will measure if there are actual Marsquakes cracking in the crust. It will feel those vibrations, those waves, or if something hits Mars, like a meteorite, and creates, it will make Mars ring a little bit like a bell. We don't know a lot about the inside of Mars. We don't know, for example, exactly whether it still has a liquid core. And that's kind of what the heat flow probe is all about too. If you think about it, if you're let's say you have a nice fire going in your fireplace or a campfire, and you've got 2 people, right? One's only 5 feet from the fire, and the other is 10 feet from the fire. Which person is going to be warmer? The one that's closer, right? And if you measure the temperature of those 2 people at the location they are at, you can determine the temperature of the fire. That's what's going on with InSight. Even though this probe is only going to go down 15 feet, there are little thermometers all along it, and the difference in temperature between what's at the bottom and what's at the top will tell them how much heat is flowing out of Mars and what the temperature of the interior is. Very, very interesting.
Sure.
Yeah, we've seen that. So, ultimately, we've sent all these spacecraft to Mars, and we want to know what happened to Mars. I've shown you the rivers. We know that Mars had rivers. There was a time when Mars might have looked like that, with a thick atmosphere and big ponds of water, maybe an ocean, right? Still have craters, but was there life? We don't know. We'd like to find out. We have some clues. So this is a map of the magnetic field embedded in the crust of Mars. When you take lava that's molten and you let it solidify in the presence of a magnetic field, that rock retains an imprint of the magnetic field. It's something that geologists call remnant magnetism. Think of a needle on a compass, right? It's magnetized. And so we've mapped the magnetic field of Mars, and we know that there must have been a magnetic field for the whole planet at some time, and the polarity changed. These are showing changes in polarity over time. This happens on Earth too. The polarity of our magnetic field occasionally flips. North becomes south, and south becomes north. And so that's recorded in the rocks of Mars. We know Mars had a global magnetic field. Why is that important? Because, think of Earth. We have in our core a lot of molten iron. And that iron is a conductor. And it's churning. And geologists know that when you get a conducting fluid, in this case molten iron, and you make it move, it creates a magnetic field. And that's exactly what's happened. We have a global magnetic field that creates a bubble of magnetism around the Earth that is like a shield against space radiation. That magnetosphere protects us from solar storms, from cosmic rays, right? And so, to some extent, you can say that the presence of that magnetic field has aided and abetted the development of life here on Earth. It protects us, it protects our atmosphere. On Mars, Mars is half the size of the Earth, right? It has 1/4 of the surface area. It has 1/8 of the volume. Go back to that campfire. I'm going to pull out 2 embers. One is the size of a golf ball, and one is the size of a tennis ball. Which one is going to cool off first? The golf ball. Thank you. Someone here is paying attention. All right. So Mars is smaller. Its interior cooled faster. We think that that's what happened with its magnetic field. The core literally solidified. No more churning, no more magnetic field, no more protection. And so now when there's a solar storm, which Earth just says, another solar storm passes around us because of our magnetic field. In the case of Mars, that solar storm slams right into the atmosphere. And it's traveling at hundreds of miles per second. And it erodes the atmosphere of Mars. It literally strips it away from the planet. And we think that over time, Mars, after its magnetic field died away, Mars has lost most of its atmosphere, and therefore its ability to be warm and have the flowing water again, right? Due to the stripping of all of the atmosphere. This is bad news. This is not a reversible process. Once it's gone, right? And yet, we want to think so badly that Mars still has life. There are tantalizing hints. This is a section of Mars. You can see the latitude and longitude. It's a pretty big chunk, right? Maybe 1/4 of the surface of a hemisphere. And this is a map made from Earth that is sensitive to the abundance of methane in its atmosphere. And the red spots are telling us that there is methane over these locations. Now, methane is an organic gas. It's natural gas. It's what most of us heat, I think, our homes with. But it is not a gas that should exist in the atmosphere of Mars, nor in the atmosphere of Earth. Earth has a little tiny bit of methane in it, and it shouldn't be there. It should be reacting vigorously with the oxygen and carbon dioxide in our atmosphere and going away. So the fact that we have any methane at all means that it has to be replenished constantly. And what is doing that replenishing? Yeah, I had a bean burrito for dinner last night. Right. Me and all my cow and livestock friends, we're giving off a lot of methane. Rotting, decomposing matter gives off methane. We tap into that, right, through natural gas wells. We're literally tapping into pockets of gas created by rotting organic matter. methane is a strong fingerprint, likely for the presence of life. Now, there are ways that you can make methane without involving life, inorganic processes. And maybe that's what's going on here on Mars. Or maybe not. But what we do know is that methane is being added to the atmosphere constantly in order to show up like this. And Curiosity has sensed this methane too from its landing site. And so here's the seasons of Mars. It's now been there for about 3 Martian years. And there is a pattern, a seasonal pattern, to how much methane there is in the atmosphere. That suggests that maybe it's something having to do with the seasons and maybe not like a herd of bison nearby, right? But we don't know, and we don't know the answer. Literally, we have not tested for life on the surface of Mars since 1976, since the Viking landers got there. And we'll have more answers in 2 years, because not InSight, but the next wave of Martian explorers, spacecraft, in 2020, will carry life-sensing instruments to test for organics and to test for actual biological activity on the surface of Mars. That's something to look forward to. We don't really know where this methane is coming from. Could be a number of things. So this search, Mars has been piquing our curiosity for all this time, and it continues. And now the stakes are getting higher, right? Because now we might not be able to claim that French Academy of Sciences prize, but we might actually be able, finally, within the next few years, to answer that centuries-old question of whether there's life on Mars. Okay, I'll come back to the present for just a second. You know, Mars and Earth are not always close together in orbit. This is how far they were apart. Here's Earth, here's Mars back in January. If you looked at Mars through a telescope, it would be this tiny little orange dot. But fast forward to now, and Earth and Mars are about to pass each other close by. And Mars is approaching one of those perihelic oppositions I was telling you about, where not only is it close to Earth, it's closest to Earth. And it's closest to the sun. In just 2 weeks, Mars will be closer to Earth, and therefore biggest and brightest in the sky, than it's been in the last 15 years. It's a great time to be studying Mars, or just enjoying it through a telescope. I showed you what pictures of Mars look like through a telescope. If you've got access to one, great. This is how the size of Mars has been enlarging since the spring, and so it's not an all or nothing deal, right? If it's cloudy on July 31st, don't freak out, because Mars will be just about as bright and big for weeks on one side or the other of that. It will get about just under 36 million miles from us, which is, this number here is the record. So it will be good, but not like awesomely great. And so we're looking forward to studying Mars, but there is a problem. Back in late May, a dust storm broke out. Remember, Mars is closest to the sun, so its surface is as hot as possible. A dust storm broke out, you can see it here, and it has spread. This is a little animation. The orange area shows the extent of the dust storm. Here's Opportunity. It is not in a good place at all. Curiosity's over here. It's less concerned because it carries its own power. These are 2 pictures taken just 3 days apart from Curiosity, showing how the dust storm has already progressed across the landscape. Not too many selfies being taken now. And this is a kind of control chart showing you what the sun would look like, that's the bright spot, with ever increasing amounts of dust in the atmosphere, what we call opacity. How much of the sunlight is being blocked? And we use a value called tau to represent that. Ordinarily, Mars is about like this, okay? By the time you get to an opacity of 11, you can't see the sun at all. Well, on June 1st, everything was pretty hunky-dory normal, and in just 10 days, it went from there to there. We've never measured an opacity of 11 before. This means that this means that Opportunity, which uses those solar panels for power, it's lights out. It's getting no sunlight, no power. It has shut down. It's in an emergency hibernation mode. It is basically fighting for its survival. It wakes up, it saved just enough power to run an internal clock. And every couple of days, the clock says, Let me send a signal to the solar panels. Any power there? Nope, I'm going back to sleep. And so it's been this way for several weeks now. NASA's very concerned that this may be the end for Curiosity because it's still cold on Mars and it needs that electricity to run the heaters to keep itself warm. So this might be the end. Curiosity, no problem. Opportunity, big problem. Well, this is a couple of pictures taken from Earth not that long ago, a month ago, showing the spread of the dust storm. The good news is that it doesn't seem to be getting any worse and it's starting to settle out. So we'll see. Maybe a little bit later this month, we'll actually be able to see some features on Mars. But you don't need a telescope to see Mars, right? I know you're all night owls. And so I encourage you to stay up late as midnight. And if you look to the south, there's no moon in the sky. You'll see not one, but 3 bright planets. Jupiter will be in the southwest. In fact, you can see Jupiter tonight as you leave. It will be high up in the south, very obvious, very bright. Saturn is making its appearance over the east, but by midnight it will be due south. And then Mars is coming along late in the month. Mars will look red to you. Not fire engine red, but kind of like Chelmsford ginger ale red. Okay, just a little peachy color to it. And this star down here, I pointed that out, that's called Antares. And remember I said, maybe I didn't say, Mars is the Roman word for the god of war. Ares was the Greek word for the god of war. So Antares means literally rival of Mars because it is also reddish looking in the sky. There's a difference. Mars is red because its rocks are rusty. Antares is red because it's a red supergiant star. But who's counting, right? It's still the rival of Mars. You can see all these things in the evening sky and they'll be really terrific. Now let's say just suppose, you can't make it to stay up until midnight, but you want to see something special. You want to take something home with you and say, Kelly told me to go look for this and darn it, I'm going to do it. You only have to wait until Sunday. Sunday evening, the 15th. Find a nice clear spot looking toward the west. I recommend the parking lot at Great Brook Park. It's got a nice view toward the west without much in the way. And start looking about 30 to 45 minutes after sunset. On the 14th, the day before, this is Saturday night, the crescent moon will be very near the planet Mercury. If you've never seen Mercury before, this is a good chance. But the next night, July 15th, Sunday night, the crescent moon and Venus are going to be very close together in the sky. This is what they will look like. Here's the crescent moon. This area is the dark side of the moon, but it should be glowing very faintly because of something we call earth shine. If you were standing on the moon there, here, looking back at Earth, you would see this ginormous full Earth in your sky. Big and bright. Bright enough to illuminate the night side of the moon. And that's what earth shine is. And then Venus is over here. This will be terrific in binoculars. Really, this is something to show everybody on your block. And you can take credit for it, honestly. You don't need to point to me. That's it for me tonight. Thank you all very, very much for your attention. Now, I'd love to take some questions. I've gone a little bit over the hour. I do want to remind you that you cannot keep the glasses. I'm sorry. So there's a basket near the back door if you can put those in as you leave. But if anyone has any questions, I would love to answer them for you. Go ahead.
Cooperation is there among the nations to further the survey?
Right. So his question is, how much international cooperation is there in the exploration of Mars? Right now, it's modest. So when the United States launches a spacecraft to Mars, like InSight, the seismometer was built in Germany. The heat probe was built in Scandinavia. And so there is, at that level, there's cooperation, right? We rely, science is a universal thing, right? Whether there's NATO or not tomorrow, there'll still be scientific cooperation between countries. And in 2020, the Europeans are going to be launching something called ExoMars on a Russian rocket with Russian participation. You know, the Soviet Union used to be like the top dog in planetary exploration, in some respects more than us. And since the fall of the Soviet Union and the breakup of the Soviet Empire, a lot of that work was funded by the Soviet Academy of Sciences, and it's just the whole infrastructure for that is just in shambles now. But there's still people there still doing work. And so that's a pretty modest level of cooperation. If we decide, however, that we're going to go back to Mars with, say, to collect samples, or to build a base, or to send people there, that's a price tag that no one country is going to be able to afford. It's kind of like the model of the International Space Station, right? It's really international. The US, the Soviet Union all contributed pieces to it. There are modules up there that were built by Japan, modules that were built by Italy, by Britain, by the European Space Agency, and everybody kind of spreads out the cost, and the end result is a collaboration that is bigger and more useful than any one nation could be. So I think what you'll see is in the future, right, those nations will partner. The sort of dark horse in all of this is China. China has a very robust space program right now. They've launched people into space. Who knew, right? They've had a space station that came crashing down a couple of months ago. Who knew? Unless you were paying close attention, they've got a rover on the moon. And they are in this game to stay. But they're kind of a go-it-alone kind of country right now. Part of the issue is that their scientific infrastructure has not benefited from interaction with the West very much. So they've basically had to learn everything from scratch themselves. But the day is coming when you'll see much more cooperation on Martian missions and others as well. Yes?
Kelly, I was curious with all those maps that showed English names for craters and
Sure.
valleys. Does everybody accept, let's say, we name?
Sure. So her question is, the names are after people, and by the way, I forgot to mention that big canyon system is named Valles Marineris, the Valleys of the Mariners. Virtually everything on Mars is either named for a famous person or for some historical, the snows of Olympus. Valles Marineris is one of the few features on any body in our solar system named for a thing. In this case, the Mariner space program, the pioneer of exploring Mars. So there's the International Astronomical Union is sort of the worldwide organization of professional astronomers, and they have committees that make decisions. So for example, when we go to Mercury for the first time, right, and we expect to find features on Mercury, the IAU decides in advance that we're going to name features on Mercury for artists and composers. And so there's a Mozart crater on Mercury and a Shakespeare crater on Mercury and so forth, right? And so that's by advanced sort of decision. And so the names that you see on Mars have been for famous people, many of them scientists. Mount Sharp is an example, right? And so this is by essentially all the professional astronomers buy into the IAU's whatever decisions they make. Now, when they do something like demote Pluto, right? There's a lot of dissension, but they're sort of the court of last authority on stuff like this.
So scientists say in Russia or in China accept the
Yes.
name.
Yes, they don't have their own set of names. And like, if you want to have a crater named for you on the moon, would you like to have a crater named for you? All right, so you got to do two things, right? First of all, you have to become famous. Doesn't have to be in science, right? Famous would be good. And then you have to be dead for at least 3 years. Okay? We'll check in with you later on that. Okay. Yes?
This is kind of a statement rather than a question, but you might be able to add something to it. I was involved with NASA for much of my career. And
You have the NASA scientist look. I mean,
in about 2005, I would say, we were on a project that included at least one JPL member, maybe a couple, three of them. And one of our members found a picture from Mars Express of a crater about 7 degrees north latitude that appeared to have a ice lake.
yes, I remember that.
Across about 10 kilometers
Right.
lake. And the close-up of it even shows frost around the edges of the crater and that kind of stuff.
Sure.
To the point about how much is their cooperation, one of the guys from JPL was certain that had to be a fake because he'd never heard of it.
Interesting. All right, so just to recap for the TV, he had worked with a team analyzing pictures of Mars at JPL, and they discovered a crater very far north that appeared to have like an ice pond in the middle of it. I remember that picture. It's very distinct. Sharp edges, you know, like you built it in your backyard, in the floor of the crater. And one of the people of the team was convinced it might be a fake. Well, we know that this ice and the water ice and the carbon dioxide ice is moving around on Mars a lot, right? And in particular, during these, especially when you get to a high latitude, if you deposit ice in a crater of some thickness, it's going to take a while for it to disappear. It has to sublimate, turn from ice into a gas. And so if you think about it, and I'm trying to remember that exact crater, but just hypothetically, the walls of the crater are going to get more direct sunlight over the course of the year than the bottom, right? Because the bottom can be in shadow sometimes. And I can easily imagine that to be the case. But it's true that there are a lot of geologic enigmas on Mars. In one of those first 3D pictures I showed you of that deep hole, that wasn't a crater. That was some sort of collapse pit on Mars. And one of the pressing questions we have right now is Mars geologically dead or not? There are places on Mars where we think we see lava flows that look very fresh. And if you count the craters around those lava flows, it would suggest that they're no more than about 10 or 20 million years old. Now that sounds like a long time, even for someone in his 60s, right? But if you think that Mars itself is 4.5 billion years old, the notion that something could be only 20 million years old, that's like yesterday. And it could be happening today, right? So you think of a volcano somewhere, like in the Philippines or in Alaska. If a scientist says, well, it hasn't erupted in the last 20 years, that doesn't mean it's dead. It's just quiescent. And so maybe there are places on Mars that are still volcanically active. Maybe there are places on Mars that are still, maybe the water has percolated. It could be an impact crater with a deep crack, right, that taps into some subterranean ice. And if you get a pulse of heat from a lava flow, it might not even have to come up to the surface. Enough to melt that ice and cause it to gurgle up to the surface, and just fill the bottom. Who knows? But I can easily imagine that and many other mysteries on Mars that kind of make us go, right? What exactly is that? Let me take 2 more questions. Go ahead.
What is the level of information sharing and coordination that's happening between the national governments or NASA and private entities like SpaceX and some of the other organizations?
Sure. There's none. It's a complete conspiracy. Her question is, how much cooperation is taking place between the government, NASA, and private aerospace companies like SpaceX? Some of you might know that SpaceX has become quite a player in the rocket business. And in fact, if you were to go down a list of rocket launches of spacecraft in the United States right now, most of the rockets used are by SpaceX, in California especially, and also in Florida. And so the answer is NASA, by definition, by its charter in 1958, was tasked with disseminating everything it knows to the widest possible audience. The telecommunications satellite industry, some of you are old enough to remember Echo and Telstar. Those were purely NASA satellites, and as soon as NASA developed the technology enough to see its commercial viability, they turned the keys over to private industry. And so right now, NASA, and especially the Trump administration, I have to say, is embracing this public-private partnership and encouraging companies like SpaceX, right, to run with it and to do as much as they can, as fast as they can. Elon Musk wants to send, in addition to sending his Tesla into orbit around the sun, he wants to send a spacecraft to Mars within the next 4 years himself, his private company. And he wants to follow that with a plan, just like Matt Damon, right, to build a colony on Mars, first with robotic spacecraft to land there and kind of set up shop, and then the humans will follow. I mentioned that the atmosphere of Mars is mostly carbon dioxide. Carbon dioxide we don't think of as a very helpful gas. But if you use the sunlight that's on Mars and break it down into oxygen and carbon monoxide, just strip away one of those oxygens and keep them separate in separate tanks. Now, well, first of all, now you've got oxygen, right? That's good. That's a good thing. And you can burn the two together as rocket fuel. So it's very valuable. And this is the kind of stuff that Musk wants to do. And frankly, there's a limit. NASA is sharing what technology they have, but he's going leapfrogging way ahead of NASA. He's doing things for far less money, far more efficiently than NASA can. NASA is a government bureaucracy, okay? And he has the power to hire and fire and get the brightest minds. There was a time in the 60s when the Apollo program was attracting the very brightest engineers anywhere in the United States to work on the space program. Now, NASA has a hard time getting the brightest engineers. They want to go to work for SpaceX or Tesla or companies like that. So it's very transparent. And I think that NASA is actually very enthusiastic and supportive of those efforts. Sir, I think you had a question back there.
The sort of sky charts that you showed at the end, for Sunday and
Yes.
midnight, are they naked eye or with the telescope?
Completely naked eye. Completely naked eye. You just walk out there and show your kids and you'll be like greatest dad on earth. And I want to mention that program is available for a free download. The program I use to plot that is called Stellarium. It's the word stellar, S-T-E-L-L-A-R, IUM.org. It's about 60 megabytes. It's open source software. It's free to download any platform, and it's completely intuitive. If you're curious, and you're curious because you came here tonight, and you have kids, or you want to find out yourself, I highly recommend it. It's completely free, no registration required. And it's just a terrific program, and you can do tricks like that, and then you'll be giving talks at the library.
I know you said no more questions.
All right. Only because you're so good looking.
Thanks. I'll give you that one. When you were showing one of the big craters,
Yeah.
you said this is the rim,
Yep.
and this is the
Yep.
depth.
You saw it backwards?
Yeah.
You saw that sometimes happens. That sometimes happens.
Does it look to me like a
Yeah,
dome?
that's right. 3D imagery is a funny thing. And by the way, you notice we don't use these in the movie theaters anymore. Now, when you put on the 3D glasses, they're using polarized light, like polarized sunglasses. And so literally on the screen, two projectors are showing one image that's polarized this way and another image that's polarized this way. And your eyes are interpreting that as 3 dimensions. And it's a great technique, and it's gone far beyond this. Folks, you've been terrifically enthusiastic tonight. Thank you. And you got most of the answers right, so yes. Thanks for that. And we'll see you again soon. Don't forget to put your glasses away.